All right. So I'm going to actually start this with an interactive piece and ask you all, when you saw the title of what we were going to be talking about tonight with fire in Washington's forests, what sorts of thoughts come to mind? Just kind of curious, and go ahead and type anything in the chat box of a thought that came to mind when you hear fire in Washington's forests. Rebirth, look at that. Health, wow. Dry summers, okay. Inevitability. You're all spot on. Maple fire, wow. We've got even some specifics of individual fire events that are particularly interesting ones. The rejuvenation process of what comes back after a fire. Climate change and fire in Washington. Changes, yeah, these forests are anything but static. Drier fires on the west side may start affecting the forests. What's going to replace them? All right, awesome. Sounds like you all are on top of it and already thinking about the myriad impacts and causes of fires, some of which we would probably throw into our positive values, some of which we'd throw into concerns as a society. All right, I am really psyched to see this comment here from Elizabeth, who's on the board of directors of Land of Trust and worried that folks don't know the difference between fire on the west and east side. Well, this will be some good material for that we're going to be talking about today. So this is great. I think one key piece that you all highlighted is that as a basic fundamental tenet to talk about fire ecology is the truism that fire is critically important to ecosystems in ways that are both positive and negative from our human values perspectives, but fire just is, right? It is a critical component, as important to these ecosystems as the trees themselves. And we'll talk a little bit about some of the examples of that as we're going through here. But fire is a dominant force that shapes these ecosystems. And here we're looking at what many of you probably imagine when we think of a fire-prone forest. And this is kind of the poster child type of forest in North America, for sure, when we think about a fire-prone forest, at least in Western North America, which is the ponderosa pine forest, which is a forest that is no stranger to the fire, and in fact, sees fire on the order of every few years to several decades under the natural range of variability. And so that's awesome. You all nailed it right on the head that fire is important to ecosystems in lots and lots of ways that we'll talk about. I would also say, and I'm surprised that this didn't come up unless I may have missed it, but maybe it is an artifact of our memories fading fast with these things. But when I was giving a talk similar to this last year and the year before, the number one thing that came up in folks' answers to that question was the smoke. And this is a picture of Seattle 2 summers ago, or almost 2 summers ago now, on one of the stretches when we had among the worst air quality in the world. And this was a serious problem across all sectors of society, and particularly for vulnerable populations. And smoky skies have certainly drawn our attention in the last several years as we've seen fire activity. Sometimes it's related to things that we're seeing that are changing with fire. Sometimes it's probably something that has been there for a very long time, long before modern societies, as well as any humans were living in this area. Smoke was something that just came with fires in these areas, but certainly have captured our attention in some pretty important ways in the last several years, as have some recent notable fire years. So I'm going to take us through a tour of just a few snapshots of some really interesting fire events that have occurred on the West Coast. So this is going to expand things a little bit from not just in Washington, but we'll start with one in Washington, which is a few summers back now in July 2015. This was, I remember learning about this fire, and I was actually visiting Washington when this fire was going on, but it was just before I had moved to start my job at UW. And this was the Paradise Fire, not to be confused with the campfire in Paradise, California, a few years after that. This is the Paradise Fire that burned in the Olympic Peninsula in July of 2015. Anybody remember anything particularly interesting or bizarre about this fire? We'll open it up to the chat box. The folks are game for that. Okay, started by lightning. Indeed, started by lightning. So naturally caused fire. The temperate rainforest was on fire and it burned for a long time. Yeah, this is still a fire that I feel like I know a few people who have been out there and checked it out. I have not been fortunate enough to be out there and actually visit the burned landscape out there, but they've described it as almost akin to landing on the moon. Not so much that it's a moonscape devoid of anything interesting or complex going on, but that it's kind of a brand new experience for a lot of people in this region to see a very severe fire that had burned through the temperate rainforest. So this was, as you noted, a lightning ignited fire, burned for several weeks in the upper Queets River in the temperate rainforest on the wet west side of the Olympic Peninsula, and burned during one of the more extreme periods of drought that we've seen in the recent records in Washington. So 2015 was a very notable fire year in Washington, mostly for the fires that were occurring on the east side. That was the year of record-breaking area burned and some big whoppers on the east side. But while that was going on, this fire was burning through the temperate rainforest. And there are some really, really interesting videos, if anyone gets a chance to ever just Google this on YouTube, of the fire behavior in this fire, actually traveling as a crown fire in some areas, not traveling and burning through the tree fuels, but through the epiphytes that are all of the mosses and lichens hanging on those big trees. And basically those things being dry enough to carry fire from one tree crown to another. So extraordinarily interesting fire behavior. Not to say that fire is a stranger to this forest on the west side of the Olympic Peninsula, but certainly it is something that we have not seen a lot of in recent history, and a very interesting opportunity to look at what fire might do in that ecosystem. That was July of 2015. September of 2017, so just 2 summers later, I was actually on my way out to study some fires on the east side that summer and was being redirected on the highways trying to get up and over the Cascades because there were a few fires burning on the west side of the Cascades that summer. This one, notably the Eagle Creek fire, burning along the Columbia River Gorge, and most notable because it is in a fairly heavily traveled recreation area, and there were winds that we'll come back to later blowing from the east to the west, blowing that smoke directly into Portland. And so it was a headline grabbing fire that caused a lot of challenges with air quality in Portland, as well as closed off that entire corridor for a long time as this fire was burning through the west side of the Cascades now on the Columbia River Gorge. Then, not even 6 months after that, December of 2017, not a typo there, December of 2017, California experienced its largest fire in recorded history of the Thomas Fire, which was burning from the period of time from Thanksgiving to New Year's through California. So not exactly what we would consider our typical fire season in most parts of the world. In California, they do have a later fire season due to a lot of the climate conditions and weather patterns there that happen that time of year. But this was a particularly notable fire in that this was burning through the holiday season and was California's largest fire to that date in December 2017. And that record held for exactly 8 months until August 2018, the new record-breaking largest fire in California's history, the Mendocino complex, burned over 500,000 acres in an area just north of the San Francisco Bay Area in the Coast Range. And so we're seeing record-breaking fires almost at the same frequency as we're seeing record-breaking temperatures or record-breaking climate events It's almost crazy to think of these things as front page news that people could be getting tired of at some point. Oh yeah, it's just another year where it's another record-breaking biggest fire ever recorded in this area. So fire activity is definitely on the rise, and we are having a serious challenge with it as a human society in places where we've got lots of people in harm's way of fire-prone ecosystems. This is November of 2018. This now is the campfire in Paradise, California, which was a horrendously tragic fire, and not the only one that occurred that year in California, where many lives were lost and many human resources and infrastructure was lost in this fire, which again was one of these fall very strong wind events of fire burning late in the fire season in California. And so just to kind of bring a big picture context to what we're thinking about in Washington right now, and some of the challenges that we grapple with fire, is we are at the same time still learning a lot about the fundamentals of fire ecology in a lot of these systems, but we are doing this on a rapidly changing landscape. And what I mean by that is very strong evidence that the planet is warming and fire activity is correspondingly increasing. Not that warming climate is the only thing that's driving fire, but it is certainly one of the key drivers of fire activity, particularly on this part of the planet in Western North America. In the last several decades, we've seen a steady increase in the decadal average of area burned, number of large fires, and in many areas, the proportion of those fires that's burning at high severity, which I'll talk a little bit about in further detail coming up here. But most metrics of fire activity we are seeing increase over the last several decades, since about the mid-'80s, when there has started to be what some would term a qualitative shift in fire activity, especially now that we've moved into the 21st century here. And that is largely due to abundant fuel that has, in some cases, increased in some certain locations, in some cases always been there in these fire-prone landscapes. And we're seeing an increasing period of time each year as the climate warms that fire is possible. In many locations around the world, fire season has expanded fairly dramatically. And in fact, the global average fire season since the mid-1980s has increased by 2 weeks, meaning the period of time between the average fire start and the average fire going out, where fires are very possible given an ignition source, has increased by 2 weeks on average over the planet in the last several decades. And in North America, the fire season, by the date that a fire has, the first date of fire detection to the last date when the fire is out, has correspondingly expanded and has become wider and wider through time, to where we almost don't talk about forest fire activity in North America in a discrete season anymore. It can happen almost any time of year in certain locations, and that period of time is lengthening over many locations. So it really brings us to a question that I think is on a lot of our minds, whether we're somebody who studies fire and forest response to fire as a career, or somebody who is interested in all sorts of interesting and important other dynamics of the natural resources, or somebody who just lives in this region and is experiencing the smoke or the closures due to fire, or potential danger to your life or property due to fire. This question of how can we live with fire is really at the forefront of a lot of our minds, and I think our region here is no exception to that. Today, in the talk, I want to help us unpack that answer, or start thinking about how we might answer that question, by talking a little bit about the role that fire has played historically in Washington, and how that is pretty different in important ways if we kind of take a broad brush and think about the east side and the west side of the Cascades. How are fire patterns changing today in both of those contexts? And then where does this leave us for tomorrow in terms of charting a healthy and safe future in an area that we know is fire prone?
Hey, Brian. I
Yes.
also just want to point out that we have 2 questions from Elizabeth here, and I don't know if they'll fold into this next part. I think the first question about was the rainforest second growth was about the 2015 fire. And then we have another question here. How much of that fire activity is related to people igniting those fires, and how much is lightning? I don't know if you want to talk about that now. Up to you.
Yeah, thank you, Catherine. I saw those out of the corner of my eye and was not doing a good job of stopping myself and addressing those questions, so thank you. Yeah, fantastic question. So the rainforest fire let me just go back so we can look at that picture. The fire that was in the Queets River, the upper Queets drainage, Paradise Fire in 2015, was actually burning through mostly, and I think almost exclusively, old growth forests that had not been logged in that area. In fact, that fire, you could look at it one of 2 ways. It killed what was previously the tallest, I believe, Douglas fir tree on the Olympic Peninsula, and in doing so created a new tallest Douglas fir tree on the peninsula when that one was removed from the record. So it was primarily the field reconnaissance that I've seen photos of from some colleagues that have been out there was definitely in some fairly old forest of 300 to 400 years old that had not been logged prior, though it certainly could have burned through other forest ages, but most of that fire was indeed in old growth and not previously logged forest. The second question, well, Elizabeth, let me double check. Does that answer your first question? Okay, great. Please let me know if it doesn't. I want to make sure I go right, zip right past that. The second question, how much of fire activity is related to people igniting those fires and how much is lightning? This is also a really, really important dimension of fire activity, and an interesting one if you look at it spatially across North America, for example. It varies quite a bit. If we take the examples of Southern California, of some of those fires that I showed you, the ratio is somewhere on the order of, the percentage is somewhere on the order of 95% of fires are human ignited, mostly accidental, occasionally intentional, but the lion's share in places like Southern California are human ignited. If you go to the Northern Rockies, say places like Yellowstone or Glacier National Park, kind of on the spine of the Northern Rockies, that ratio is flipped, but not so dramatically, to where it's about 2/3 lightning caused and 1/3 human ignited. And even in Washington, that's variable across space. And it usually corresponds, no matter where you look at it, across anywhere on the planet, corresponds to human population density, not surprisingly. And the more people you have in a landscape, there's a greater correlation with an increase in human-caused to naturally lightning-caused fires. Does that answer that one, Elizabeth? Okay, great.
Thanks, Brian. That was really helpful.
Yeah, no problem. These are great questions. Keep them coming, and I will be better at stopping myself here. Get too carried away. Okay. So yeah, I'm gonna walk us through this conversation, and again, feel free to fire off any question. Pun intended there. Fire off any questions as they come up here. I'm getting good at the dad jokes with a 5-year-old in the house here. Right. Okay. So let's first look at this idea of fire in Washington and 2 sides of the mountain. If I was to show you a map, like I am here, of fire activity since the mid-1980s through 2017, and this could have been updated to 2018 now that we have those fire year data, but the story stays the same through 2017. And I was to ask you a question, what proportion, oh yeah, sorry. One other key thing here, this dashed line that goes down the middle of the state, as some of you may recognize, is the Cascade Crest. So essentially, left of that, west side Cascades, right of that is the east side of the Cascades going into the Palouse region. So if I was to ask you what proportion of fire activity of the over 2 million hectares of fire that has burned since the mid 80s in Washington has been on the west side of that Cascade Crest, what would be some guesses of what proportion or what percentage of fire would be on the west side of the Cascades in the last 3.5 decades? Less than 3. 1%. All right. Got some strong wagers here. 5%, 0.5%. Okay. No one's going to go bolder than more than 5%, which is understandable looking at this map. 0.1% from Debbie. Okay. Just for fun, I'm going to leave you all hanging on that, and we will come back to the answer when we look at another map here. The question was the percentage. Yeah, sorry. What percent of this red area, which is all the fire activity in the last several decades, what percent of that is on the west side of the Cascades? And so we've got answers ranging from 5% at the high end to 0.1% at the low end. Okay. I'm going to leave you all hanging, and we'll come back to that because it's an interesting answer. Clearly, from this photograph or from this map, we can see that by far the majority of it is on the east side of the Cascade Crest. And we see a few very small fires. Just to point it out, this is that Paradise Fire in the Upper Queets drainage. Oops, where's my cursor? Can you all see my cursor there?
Yeah, we can.
Okay, cool. And then we see a few that are sort of like poking over, maybe straddling the edge. Oh, we've got Barbara going up to 10%. So we've got a new high guess, ranging now from 0.1% to 10%. Awesome. These are all fantastic guesses. So we'll come back to this, I promise. What's important to think about, and I'm going to unpack this in several different ways as we're going through this, is that fire is actually no stranger to either side of the mountain. It just really comes down to scale, and temporal scale being one important dimension that we'll look at in a little bit. And so I'm going to walk us through what I would consider the two archetypes of fire or forests that are impacted by fire and have some adaptations that correspond to fire. One on the west side, one on the east side. On the west side, we're going to be talking about the Douglas fir western hemlock forest, which I'm guessing in this crowd, many of you probably are aware is a forest that experiences fire, but that comes as a shock to a lot of people in this area that those forests could ever burn. And then the more obvious one, again, is the archetype or poster child ponderosa pine forests on the east side of the Cascades. So we'll use those as kind of our bookends, realizing that there's a lot more messy complexity out there, but these are two helpful bookends to think about fire on both sides of the Cascades here. And then really quick, a one slide version of Fire Ecology 101 here. I'm going to be talking about two key things when we're going through these different examples. One is the fire regime, which basically comes down to the repeated characteristics or patterns of fire over a long period of time and over a broad spatial scale in a particular ecosystem. And that's this information on the left here. Basically comes down to how often do fires burn, how big are they normally when they do burn, and how severe are they when they happen, or in other words, how big is their effect? What sort of impact do they have on the ecosystem? Do they kill a lot of trees? Do they just scar trees, but a lot of trees survive? So we'll talk about the fire regime on both sides of the Cascades. And then the other important piece of Fire Ecology 101 is what's the control of fire activity in that area? What's the main constraint to fire happening? Is it that fuels are limiting and that's what would have kept fires in check? Is it the weather conditions that are limiting and that's what would have kept fires in check? Or is it ignitions? Is it an area where the weather would have been suitable, there's plenty of fuel, but nothing ever would have ignited naturally or even potentially during indigenous populations in this area over the last 15,000 years. So we'll be talking about the components of the regime and the controls on that regime in both of these two sides of the mountain. So seeing as that none of us get to travel a whole lot right now, I'll take us on a little bit of a virtual field trip to an area where we've got some research going on, which is just kind of a nice archetype location to think about the ponderosa pine forest. And that is on the east side of the Cascade Mountains in the Mission Creek area on the Okanagan-Wenatchee National Forest, just near, basically just south of Kashmir and kind of southwest of Leavenworth. So the lower stretches of the east side of the Cascades, almost to where you'd be transitioning into non-forest out into the plains and Palouse region of Washington. And so this is it's a useful place to think about fire ecology because it is a very regularly warm and dry location throughout the summer, as many of you I'm sure have experienced hiking around or potentially living in this part of the state at different times. And so when we think of, oops, let me go back really quick. The dominant tree in this location is very well in tune to the fire regime and the controls of that fire regime in this location. And so we're looking at right here a ponderosa pine tree that has a nice, what we call a cat face fire scar on it, where fire has scarred the cambium of the tree. The bark has grown around that, and that tree is now prone to more and more scarring from fires, but it's got thick enough bark that it can actually survive the kind of fires that would have occurred in this landscape. And so the environmental conditions in this part of the Cascades are such that any given summer, for the most part, it would have been the rare summer historically and the rare summer now where you would not be able to get a fire started on the east side of the Cascades, and particularly at low elevation on the east side of the Cascades. So the environmental conditions, particularly the weather and climate, has been conducive to fire for a very long time in this part of the world and will continue to be in the future. There would have been plenty of natural ignitions from lightning ignited fires, as well as over the last 10 to 15,000 years, plenty of human-caused ignitions from indigenous populations through to today in intentional and accidental fire ignitions. And so what would have kept fires in check in this part of the state historically would have been the limit of fuel. So I'll walk us through why and how that's going to work in a second. But basically, we got the conditions for fire any day throughout most summers and plenty of ignitions out there. So as long as you got fuel to burn, you're good to go. And these things are pretty locked in this location. So historically, what that meant on the east side, and particularly in these low elevation ponderosa pine forests, is that fires would have been fairly frequent historically. And by frequent, I mean, in some areas on the order of every few years, fire would have come through. And on the high end, it would have been several decades. And then as you move up the mountains in the higher elevation, that starts to change. You get a little bit less frequent and perhaps more severe when they occur. But in the low elevation ponderosa pine forest, as that example again, fires were frequent. And what that meant is fires coming through every few years to several decades would have removed a lot of that fuel. And so we're looking at a photo in the background here of 1 year following a fire, and you can see that most of the woody vegetation has been burned off. There aren't a ton of trees between some of these widely spaced trees, even though this is actually a fairly young forest here. But those frequent fires would have come through and removed a lot of the grassy understory, a lot of the shrubby biomass, and certainly a lot of the lower branches on any of these ponderosa pine trees. And because they have thick enough bark, they would have been able to survive those fires. And those fires would never have gotten very intense, meaning lots and lots of heat over wide, extensive areas, because with fire coming through relatively frequently, that would have kept things in check. It would have kept the fuel level down. And so if you're a tree in that location, it really pays to have this fire adaptation of investing a lot of your resources over the years, decades, and centuries of your life into thick bark, because you can bet on the fact that fire throughout your evolutionary history is going to be fairly low in intensity, and therefore you're going to have a good chance of surviving that fire. And so ponderosa pine, again, is kind of the poster child tree, where on some of these really old ponderosa pine trees, you can get bark that is getting up to a foot thick in some locations, and is providing solid insulation for these fairly low intensity fires that would have been by definition then low severity, because things would have survived. Lots of trees would have survived. And if you walk around in the Mission Creek area, you can find lots of these medium to older trees out there, middle-aged to older trees that have these fire scars on them. And if you were able to cut into a cross section of one of those, and you could do this, people have done this all across the West, you could look at every year that tree experienced a fire, it would have created a new fold on a new fire scar over that bark wound. And a lot of fire history is done by taking these cross sections and counting, or basically accounting for all the fires that occurred. And historically, that's exactly the information that we would have used to characterize these fire regimes, is you can then figure out an average frequency of fires across a large enough space by taking enough of these scars from these old trees that survive those low intensity and frequent fires. Yeah, Elizabeth asks another really good question here. Given that native people have been here for thousands of years and fire was both intentional and not, could these trees have evolved because of human interference, or in this case, human ignition of fires? That is a really, really good question, and one that is answered kind of in two ways. One is that these trees are fairly long-lived organisms. And so over the period of time where there's been human settlement in this area over the last 10 to 15,000 years, that's a long time period. But in terms of generation turnover time of these trees that live, can certainly live to be several hundred years old, it's not a long enough time to really drive an ecological adaptation to fire that wasn't there prior to humans arriving on the landscape. So it's probably a stretch that these trees have, well, they certainly did not evolve this adaptation to fire because of humans. It may have been selected for based on increasing fire activity because of humans being here in the post-glacial era, in that the relative dominance of trees like ponderosa pine could have increased on the landscape, but their evolutionary adaptations would have been locked in from long before the last 10 to 15,000 years of human settlement. And we know certainly that fire was a part of this landscape through longer term records like charcoal records that predate human settlement in lots of parts of North America as well. So yeah, fantastic question. And I think the main effect would have probably been on shaping forest composition to favor conditions that would have resulted in maybe more ponderosa pines on the landscape relative to other trees. Another great question. What about the effect of pine bark beetles? It seems as though there are many dead trees in eastern Washington just waiting to burn. Fantastic question. And in fact, most of my research prior to coming to Washington that I had been working on in the Rocky Mountains was looking at that exact question is, do the insect outbreaks make fires worse or more likely to occur, or more ecologically profound when they occur? Really, really, really good question. And it has been a huge concern over the last several decades in North America, as we've seen, certainly in Washington and even more severe in some other areas of the Intermountain West, severe beetle outbreaks that have caused, in some cases, 90% mortality in the host trees. What's a little bit surprising in all of the research that I've done, as well as most every study that has looked at this, has kind of circled around these same relative findings, that in the last several decades, there has been an increase in bark beetle outbreaks, there has been an increase in fire activity, but in every which way that we've tried to find a direct link between the two, there's very little evidence that bark beetle outbreaks are leading to more fire activity, meaning the studies that have looked at that have shown that fire area burned or fire activity is just as likely to occur in forests that have not had bark beetle outbreaks than forests that have had bark beetle outbreaks, all else being equal. So fire occurrence has not been shown to have a strong dependency on bark beetle outbreaks. And then when fires do occur, the fire severity or the ecological effect of that fire has had some very nuanced responses, where under certain conditions the fire is actually less severe when the fire burns through a beetle-killed forest, and in other conditions the fire can be slightly elevated in its severity. But the large sort of massive gravity of the research that has looked at this has basically found no strong effects on fire severity in beetle-killed forests either. What's different from that, and is also a very important dimension of this, is firefighter safety and actual fire behavior when fire is burning through beetle-killed forests. There are different ways to ask that question, and one of them that's perhaps the most important is actually observations of fires when they're burning in these areas, and most importantly so by firefighters that are on the front lines of these operations. And there has been some evidence to suggest that the fire behavior is harder to control or manage from an operational perspective in beetle-killed forests. And certainly navigating fire operations in a beetle-killed forest is going to be more challenging, because you've got more down wood and or snags, standing trees that could fall down in the middle of a fire. So it's a very, very, very good question. And I would say it really comes down to two types of answers to that question. Operationally, from a fire management question, the answer would be it has made it more challenging. From an ecological perspective of have fires become more likely or more severe when they do occur in beetle-killed forests, the answer is equivocal at best in terms of there being any link or connection between those two. What's often kind of the then like, okay, then the answer of the why are these two things happening is they're both very strongly responding to a warming and drying climate. That drives fire activity for sure, and a warming, drying climate stressing trees that in some areas may be because of a lack of past fire or synchrony from past fire events, in terms of a bunch of trees being susceptible to beetles and now stressed from a warming, drying climate. That is also a big driver of the bark beetle outbreaks. And so those two things are being driven by, in part, by one key driver, but may not necessarily be mechanistically linked together. Is that a helpful answer, Elizabeth? Great question. How about, if I promise, can we come back to the the beetle fire stuff at the end, these are fantastic questions. But I feel like given my my interest in that subject, I could end up talking about it for the rest of our time here. So yeah, okay, cool, thank you. Let's come back to those for sure, because they are awesome questions, and that question actually depends on tree species, which is kind of an interesting and important component of it. Okay, so back to east side, fire adaptations of dominant trees. It paid, evolutionarily speaking, in this system to adapt thick bark to be able to survive fires when they occur, because they would have come frequently. You could bet on fire coming, and when it came, it wasn't going to be that intense. You could survive it. Historically, what that meant for forest structure in these areas was something on the order of this, right? Realizing that it would have been certainly variable across space and time historically, but throughout most of the evolutionary history of these species, as well as certainly the last 10 to 15,000 years, we would have seen ponderosa pine forests in a structure somewhat like this, where those relatively frequent fires would have come through and burned off a lot of the surface fuel, burned off a lot of the smaller trees, and just scarred but not damaged the larger trees. And so it would have led to this almost woodland-like structure, right? In a lot of areas, we talk about the ponderosa pine woodland because the forest would have been relatively dense, or sorry, relatively sparse, and in some areas there would have been more open canopy than actual closed canopy in terms of the forest structure. That's historically. Over the last 100 years, we have first through lower technology fighting fires on the ground in the early part of the 1900s, and then later on post-World War II with more and more increasing technology, we have effectively suppressed and or excluded fire from a lot of these historically frequent fire forests in the warm, dry forest ecosystems. And that is really important for a couple different things. One, it has in many ways shifted our collective societal understanding of these forests, because I think my personal opinion on it is that that has led to, at least over the last 100 years, people probably not having as much of an appreciation of the role that fire has played in these forests historically, because they haven't seen it, because we've been very effective at this over the last 100 years. And going back to that tree ring record, it's really striking if you look at these fire scars in the dry forests throughout the West, and you see them occurring every few years to every decades across space, across lots of different forests, and then all of a sudden, in about the early 1900s, you just see that wholeheartedly stop across a lot of these forests in eastern Washington, Montana, Idaho, and all the way down into places like California and the desert mountains in Arizona, New Mexico. And so that effective fire history, that effective fire suppression has come at a cost to the forest structure and now the potential fire risk in a lot of these forests. This is a photograph of the Mission Creek area, and I'll talk a little bit about this this study site in some other slides in a little bit, but in one area where fire has effectively been suppressed and there hasn't been fire for probably near 100 years, in this particular area where this photo was taken, and you can see these old ponderosa pine trees with the thick bark that are adapted to survive fire are still there, and in some areas are struggling because they are stressed from being crowded by their neighbors. In other areas, they're doing okay, but they are surrounded by an entirely different fuel structure than they would have been historically through their evolutionary history. And so in this particular area, we're looking at a forest stand that is characteristic of many areas in the low, dry, frequent fire forests historically that now have, in some cases, 2 to 3 times the tree biomass that they would have had historically on them. So lots of carbon being stored on these forests, but in perhaps a fairly precarious state, because we know these forests will burn again at some point in the future. And most, if not all, of the trees in this picture lack adaptations to be able to regenerate following a high severity standard facing fire. Most of these trees in the background are shade tolerant trees, like we see some Douglas fir on the east side, which is a relatively shade tolerant tree on the east side. We also see some grand fir in the background there. Those trees are, grand fir is basically not very fire adapted at all. And ponderosa pine, once that tree dies, it's no longer going to be there to produce seed to reseed in that area. So its thick bark is only going to protect it to some level of fire activity. But when that fire gets so intense with the fuel structure around it, it's not going to be able to survive that fire when it does occur inevitably in these areas. Brian asked a really good question about how does the priority of DNR, Forest Service, and BLM affect the health of the forests? Really good question. And it's a slightly different management context for each of the different management agencies and landowners across our forests. Let's come back to that specific question once we maybe get to the end of what can we do about this in some of these areas. But it's a really good question. Jenny and Steve asked, what's the fire response to other forest management decisions such as planting for single species and all of the same age class? Yeah, so another really good question. I can answer that one quickly in 2 slides here. I think it will be a good example of how we might look at this. Elizabeth asked a really good question. Who defines what a healthy forest is? That is a fantastic question. I think it's in the eye of the beholder. We can think about it from the evolutionary history of a lot of the species here, and they may have a certain lens in terms of what they stand to gain or lose being in these forests. We can think about it from the values that we all have individually and collectively for forests. But I think from an ecological perspective, a healthy forest is one that has lots of variability and heterogeneity in it, including live and dead trees, including disturbance, including high biodiversity. But again, that may be a very different answer from healthy from an economic standpoint, or from a recreation standpoint, or from a certain wildlife species standpoint. Okay, let me come back to the question about how do we respond to these fires, because what this challenge that we're seeing right now in this photo has led to today is a serious concern about fire activity in areas like these historically frequent fire ecosystems, in the warm, dry ecosystems. Because when we see fires happening today, when they're burning under these higher fuel load conditions, it's of major concern, because historically these were not weather or climate limited systems. Remember, those conditions were always there. The ignitions have been there for the most part. What used to keep fires in check or keep fire severity in check was the limitation on fuel. And basically we are removing that limit when we're increasing the biomass by 2 to 3-fold, and sometimes, or 2 to 3 times in some of these forests. And so here's a picture of one of the large fires that we've seen in the last several decades, or several years on the east side. And this is the challenge that we're now faced with, is when fire does burn in these areas, going back to this question from Jenny and Steve, what do we do now? Because I think in some cases, the knee-jerk reaction would be to go back and replant these forests and get trees back on the landscape as soon as possible. That may make sense, and that may be exactly what we want to do if getting merchantable timber out there soon so that it can be harvested for economic gain is a goal, or if getting forest cover is a goal for any other purposes. However, to your question, what we want to probably be careful of in these situations is setting these forests up for being in sync for high susceptibility to disturbance in the future, right? And so we want to probably avoid getting into the same challenge that we are currently in with high fuel loads in these. And again, it's gonna differ by management context, but you know, planting in ways that generate variability in the forest structure, planting in ways that introduce that heterogeneity back into the forest that would have broken up these contiguous patches of fuels historically, is one way that we may, one option that's on the table for mitigating future fire risk or other disturbance activity. And so this is a big concern, because in this photograph right here, there's, again, none of the tree species that we're looking at right here have an adaptation to be able to reseed following this fire. This is mostly thick bark ponderosa pine, and then lots of grand fir in the background. And a standard placing fire comes through and burns if it burns a large swath of those, you may be limited in terms of seed to regenerate that forest, because these species don't have things like the closed cones or resprouting capacity following a fire if it's a high severity fire. And so on the east side, the management challenge and context for a lot of landowners, again, it's going to vary depending on context for sure, but is how can we set these forests up for a more resilient future? One of the key frameworks that a lot of landowners are using is this idea of resilience. We can't necessarily stop fire from inevitably happening, but what we want to do is set these forests up so that they are able to better respond to a fire in terms of being resilient, being able to persist and or bounce back following fire. And so this series of photographs is, you know, thinking about what these look like historically and thinking about what a lot of areas look like today. Choosing our future for tomorrow is really something that we have an opportunity to do in some of these areas, but it's going to depend on management context. In this case, this was a thinning and prescribed burning treatment that was done in one of our study sites almost 20 years ago. And that was an area where it was an experiment set up in the Mission Creek area to see what those treatments could do in terms of reducing fire risk and in reducing the fuel accumulation there. And so it's one of the areas where we're tracking the long-term trajectory of these fuel treatments and basically asking the question, how effective are those going to be in terms of reducing the intensity and therefore the severity of the inevitable fires when they do come back to these landscapes? So that's the east side, and that's probably the more familiar fire story that I think most folks are thinking of when we think about fire-prone forests. What's interesting in Washington is that we've got fire-prone forests on the west side too. It's just on a very, very, very different time scale and type of fire regime. So on the west side, like I said at the beginning, we're going to talk about the Douglas fir western hemlock forest as, in some ways, the poster child of a forest ecosystem that has a very important relationship with fire, but in an extremely different way than our east side ponderosa pine forests. And for this one, I'm going to take us to one of our study sites, which is on the Mount Baker Snoqualmie National Forest, looking across at Mount Rainier. This is actually, believe it or not, one of the reasons why I have to pinch myself that this is my job. This is one of our summer study sites here that we went to last year and the year before, and we'll be going back to this year, because this was the location of a recent fire that we'll look at. So in these forests, we've got very different environmental conditions than what we have on the east side of the Cascades. West side of the Cascades, any given day in the summer, it's going to be a lot harder to get a fire started on the west side of the Cascades compared to the east side of the Cascades. So the period of time when burning or fire is possible on the west side of the Cascades is not absent every summer, but is going to be on average much shorter every summer. And so what that led to historically in these areas is really long intervals between fires, because they would have been weather or climate limited in this area, meaning most summers it would have been pretty rare to have the conditions to get a big fire going. Certainly that happened historically and has been happening in the last couple of years, and we're expecting it to happen in the future. Even if the climate wasn't changing, that would be happening. As we know, fire is a key part of these forests. But when those conditions were suitable for it, it would have been so long since the last fire that there would be plenty of fuel to burn. And these forests were probably at the opposite end of the spectrum in terms of thinking about weather and climate being their limit and fuel not being really a limit at all, as it was on the east side of the Cascades. Again, ignitions on the west side would have been a combination historically of lightning caused. Certainly we know that that can happen and has happened naturally for a very long time on the west side. And then throughout the last 10 to 15,000 years, human ignitions would have added additional fire starts on the west side. And so what's a little bit crazy to think about is we see a picture like this, and on the east side, we'd be screaming, oh, wow, this would be a horrendous ecological outcome and management outcome in a ponderosa pine forest at the low end of the forest zone out by Wenatchee and Kashmir. Again, on the west side, this would have been exactly what we probably would have seen under historical conditions. When fires would have burned, they would have been burning during periods of time when it was warm, dry in the summer, and similar to what we see or know about in Southern California, where they call them Santa Ana winds in Southern California. We'd have a high pressure system that sits over the interior part of the state and blows winds up and back over the Cascades, to where by the time they come down the west side, they are really warm and really dry, and often cases when they're being blown by those systems, really fast winds. And so it creates the perfect storm if there's an ignition on the landscape for fires to become very large and very severe pretty rapidly when they would occur on the west side. So it would have been fairly infrequent. And when I say infrequent, on the order of, on average, a given patch of forest would have probably burned every several hundred years. So we're talking fire return intervals of 300 to 500 years. So if we look at that map, going back to our question earlier, so I asked you all what proportion or what percentage of fires is on the west side of the Cascades. I swear I feel like this is an infomercial when I give the actual number here, and you all were so close, and somebody got as close as I've ever seen to this. The true answer is less than 0.1% over the last several decades of this fire activity has been on the west side of the Cascades. And that's this map that shows us from the mid-1980s till now. However, it's a little bit of again, it's a false representation of what fire probably was historically on this landscape, because we know periods of very little fire activity over a couple decades probably would have been very common historically, because fires were so relatively infrequent on this side of the Cascades. And here's a map of that. The same outline here is the Cascade crest. So we're only looking at forests on the west side of the Cascades. And these three colors are three forest zones. This is a figure reproduced from some colleagues, Dan Donato and Josh Holofsky, who led this paper, who basically in this map, they show that fires would have been occurring about every 400 years in this green zone in the western hemlock Douglas fir, every 450 years in the silver fir zone, and then as you get higher up into the mountain hemlock, every 750 years between fires. So when fires are occurring that infrequently, they're going to be really severe when they do come, because there's so much fuel and biomass just naturally and inherently ready to go in these systems. And we know from the historical record that that has happened even in our more recent documentary record. The Yacolt Burn in 1902, in a series of 2 days, burned most of its 500,000 acres on the west side of the Cascades. This was in an area just south of, basically between Mount St. Helens and the Columbia Gorge, where this fire burned from east to west and was burning downhill through most of its extreme fire progression during one of those periods of very strong, warm, dry east winds blowing up and over the Cascades and pushing fire out to the west. And again, this fire in 1902 burned over 500,000 acres in that single fire event. We also know from lots and lots of work from people who've been looking at this for a long time at UW here. This is Miles Henstrom and Jerry Franklin from early in the 80s, where they went out in Mount Rainier. They basically reconstructed a fire history by coring trees all over the place and creating these polygons of what were past fire events in these different years, and basically came up with, in Mount Rainier National Park, the fire rotation, meaning the amount of time to burn the area equivalent of Mount Rainier National Park would have been about 450 years, or in other words, several centuries between fire burning an individual patch of a forest out there across most of the Western Cascades. And so what's interesting and very different from what we think about on the east side of the Cascades is if we saw a forest structure like this on the east side of the Cascades, we'd probably be thinking, wow, this thing is way out of whack and is way overstocked and high dense and high biomass and is in serious jeopardy of high fire risk. On the west side of the Cascades, this is par for the course, right? If you haven't had a fire for several centuries or half a millennia or more, you're gonna get to a lot of biomass. And in fact, our old growth forests that we know and love on the west side of the Cascades that are among the highest biomass in the forests in the world are that way because it's so long between fire events. But we do know that these forests were born of fire and big fires and severe fires several centuries ago. You can find that in the charcoal record here. You can find that in the fact that Douglas fir, which is the early post-fire pioneer colonizing tree on the west side, all established around the same time, about 400 years ago, in where this picture was taken. And without fire, or the opportunity presented by fire, they would eventually disappear from this forest and be replaced by western hemlock, western red cedar, and other shade-tolerant trees, because Douglas fir has a really hard time regenerating in the absence of a stand-replacing disturbance like fire would have been historically, on the west side, at least. So again, here's that little Douglas fir tree seedling. It is in its best opportunity to regenerate following a stand-replacing fire. This is a fire, this is 1 year following a fire on the west side of the Cascades, and a Douglas fir seedling that you would never see surviving in the shaded canopy or the shaded understory of an old growth forest, or very rarely see surviving in the numbers that you would see following a stand-replacing fire on the west side. The west side, very different story in terms of the land use or management over the last 100 years. Sure, we have applied similar fire suppression on the west side as we have on the east side of the Cascades, but whereas on the east side, the last 100 years of effective fire suppression means we could have missed in some areas 5 to 10 fire events potentially. If you've got a fire regime that is several centuries long and you effectively suppress fire for 100 years, you more than likely did not actually miss a single fire event. And so fire suppression on the west side has had much less of an impact on the forest structure that we see today. And we've got a different legacy of land use on the west side, where these forests have been logged and we've been managing them for other reasons on the west side. And so one way to think about that is forests on the west side are probably not higher biomass or higher fuel than they would have been historically, but in many areas are likely lower biomass and lower fuel than they would have been historically under that natural fire regime, because through logging we're removing biomass and therefore removing fuel in a lot of these areas. So it's a very different legacy of of land use and management and how it intersects with the fire challenges on the west side. So changes to forest structure and fire risk on the west side, not as much in terms of the fuel component or the forest structure component. Really, the change to fire risk on the west side is more likely due to what was previously the climate window that would have been suitable for fires probably becoming longer and longer, and more opportunities for fires to burn on the west side than there would have been historically as we get a warmer climate. Some fires that we see today on the west side, and some interesting context and opportunities they provide. This is a photo of the North Peak fire, and you can see Mount Rainier in the background there. So this is one of our study sites on the Mount Baker Snoqualmie National Forest. Interestingly, this fire started by a lightning ignition on the east side, on the Okanagan-Wenatchee National Forest, was burning slowly up the hill on the east side, and then one of those mini east wind events pushed it up and over onto the west side, and it blew down from the Cascade Crest almost all the way down to Highway 410 between Greenwater and Crystal Mountain in that area. And in total burned about a little over 20,000 acres on the west side of the Cascades, and a few more than that on the east side of the Cascades. So that's one that's kind of like draped over the Cascade Crest. And what's interesting about this fire is it's in that less than 1% of fires in recent decades that have burned on the west side of the Cascades. And so whether or not this fire is something we should be concerned about from an ecological perspective is much more of an open question, likely with an answer of no, meaning this fire is probably one of the smaller fires that would have occurred historically. And we know that fires historically were high severity, and we're doing a lot of research that's characterizing this fire right now. But really, we don't have the same information to compare as we do on the east side, because we've got a ton of data to work with on the east side where all that fire activity has happened. On the west side, we have so few data points that really is an opportunity to go in there. And what we've only previously been able to do by looking in the rear view mirror of old forests and looking back at fire events that we can presume happened several centuries ago through our sort of retrospective lens, now we have an opportunity to go out there and actually measure things in real time in the very early stages of how this forest is responding and bouncing back to fire. So a lot of our current work right now is actually measuring some permanent plots in collaboration with a lot of different partners and land managers that we have out there, and basically tracking year after year after year what's going to be coming back in this forest. And it's a really interesting context that we have there, because we have plots that were in old growth forests when they burned, plots that were in areas that burned about 130 years prior to the North Peak fire in an old fire that we have records of, and then plots that were in 40-year-old plantations that had been logged and then replanted that then burned in this. And so we have an opportunity to understand the role of these fires in today's landscape in this area. And I would say it's hard to really talk with much conclusions about fire on the west side, because it's a very active area of research right now with a lot of folks and partners that we're working with here. And so this is just one of the things we're also doing, just to kind of show you a fun satellite's eye view of that fire. This is here's the White River, and Highway 410 kind of parallels that. Mount Rainier National Park is on this side. Crystal Mountain Ski Resort, and actually you can see some of the ski runs in the light right there. And then these red areas are the high severity burn patches in the North Peak fire. And so some of the work we're doing right now is characterizing and quantifying those burn severity patterns, as well as tracking how that forest is going to respond to these fires. And what's a very interesting context to think about here is west side forests, very dependent on post-fire regeneration when a high severity fire happens, right? These even thick bark Douglas fir on the west side, in a high severity fire, most of them are going to get killed. And so they really depend on that influx of seeds coming in to start that next generation of the forest coming back. It's a little bit crazy to think about how this 1-year-old tree seedling right here is going to be growing up in a qualitatively different environmental context than its parent tree, where that seed came from, that had established several hundred years ago in this landscape. And so there's a big lag and time gap between generations of the Douglas fir trees, at least in this region, when a fire comes through. And so thinking about how that environmental space is perhaps different for these tree seedlings is something that we're interested in tracking and how they're doing following some of these recent fires. And then finally, a big challenge on the west side is that these fires are much closer to human population centers. And that's going to be very important for thinking about immediate and very close to population smoke impacts, as well as fires in a very highly populated wildland urban interface on the west side of the Cascades, where it's really challenging to address fire and fire management in this area, where fire is inherently harder to tame because of the fire regime on the west side, and we've got lots of people living in close proximity. So when we think about, I'm going to close up here, and then I know there's a couple questions that we can get to in a second. I've just got a few more slides. How can we live with fire in these landscapes? When I think about this and try to engage in a conversation with folks, I think about one key piece is learning about the role that fire has played, does play, and will play in Washington's forests. Most of what I've been showing you is what we know about fire history in these areas. We've got, I showed you some pictures of some of the study locations where we're studying currently what role fire does play. And we know from all of the best science on projections in the future that fire will continue to play a role in Washington's forests. And in some areas, we're expecting to see pretty dramatic increases in at least the potential for fire to occur as the climate warms. And so learning about that is really key. And that's one thing I would say I'm really stoked to be able to chat with you all tonight. And I'm excited when folks want to learn about this. And I have this obligatory photo of my now 5-year-old son in here as a reminder of, it's also really important. I teach at the university here in Washington, but it's really critical to get the younger generation engaged in these topics. And I know that's something that's probably on a lot of your minds and your organizations, is engaging the next generation of folks who are going to need to be literate in a lot of these ecological contexts and the management contexts and challenges and conservation challenges that we're interested in grappling with them. And so I start right here at home with my son Joaquin, and then I'm always happy to do talks like this and learn from other folks as well, for sure. The other thing that I think is really key is preparing our communities and talking about the fire reality in Washington. And so one of the groups that I would recommend if folks are interested in engaging with, and I think is a really, in my opinion, a shining beacon in a lot of this work for promoting exchanges of information, is the Climate Impacts Group at UW. And they organized a series of workshops about West Side Fire in the last year, and brought together stakeholders from different sectors of society who are interested in this from lots of different angles. People who are thinking about it from emergency services or municipalities and water supplies to ecological impacts and land management. And they've got a lot of really good resources in terms of nicely combined information packets on this to help distribute, as well as they are a stellar group with bringing together a lot of insights and on the ground knowledge and concerns about a lot of the ecological impacts that we're thinking about in Washington. And they're housed in the Ecology of the Environment at UW, but I know they interact with a lot of partners throughout the state and region. And then finally, acting locally. So no matter where we live, I think it's really important to, in some cases, do whatever we can to protect ourselves and our communities from fire, even though in some cases that may be decoupled from ecologically what we might want to do, right? And so one of those things is, even on the west side, where I would say ecological restoration of fire is a different thing than we think about on the east side, and maybe there's not as much that we need to do in terms of restoring these big, bad, severe fire events. We might still really want to do things like protecting our communities and our homes. And one of those things that is really effective, no matter where you are, at the local level around your home or around communities, is treating the fuels in those strategic locations. This is a photo of the Carlton complex, which was one of the big East Side fires, and some work by a colleague of mine, Susan Pritchard, who is at UW and also works with the Forest Service, has done a lot of work that is demonstrated in these large fire events. Now this one is on the east side here, Carlton complex. In these large fire events, areas that were treated for fuels, meaning those fuels were reduced, and particularly around homes and valuable resources, the fire severity or the intensity of that fire drops substantially. And so it really gives firefighters a chance to be able to protect and prioritize those structures where there is defensible space around them and where there has been some reduction of fuels. Now, on a widespread level, we know a lot of work shows that widespread thinning across forests is not going to stop the occurrence of fire or even total area burned in many ways, but it does have an impact on, in a given area, is that fire going to be more or less severe or more or less operationally feasible to go in and perhaps save a structure or a home. So doing those in strategic locations is particularly important. And then finally, I'll just end on this question of what would our forests look like without fire in Washington? And one way to try to imagine that thought exercise is imagine East Side Cascade forests without ponderosa pine, because that's what they would look like without fire if we just didn't have fire in these forests. Or West Side Cascade forests without Douglas fir, because Douglas fir's primary opportunity for natural regeneration is following a standard placing fire. So fire is so integral and baked into the ecology and biology of the species that dominate our forests and that are really characteristic of these forests, that trying to imagine these forests without fire in them is like trying to imagine East Side forests without ponderosa pine or West Side forests without Douglas fir. It's almost impossible to do. And I think that's, for me, a really key reminder of the role that fire has, does, and will continue to play in our forests when we think about these two sort of poster child trees here in our forests. With that, that was a long time to talk there. I'm excited to dive into some questions. I just want to say thanks for spending some time this evening and engaging in this conversation. So let's chat.
So it looks like
Brian, I think you've got a number of questions in the chat. You probably have them there. Can you take a crack at some of those?
Sure. Yeah, there were a couple that came up. There was one from, oh yeah, Elizabeth had the question earlier on that I said I would come back to about beetle killed forests and a fire and does the pre-fire beetle outbreak change how that forest may respond following fire? This was actually a fun topic, was one of my dissertation topics for my dissertation research when I was in grad school. And basically, we and a lot of others who have looked at this came up with a similar conclusion that it depends, which is the fun ecological answer. For a tree species like lodgepole pine, which is a prolific post-fire recolonizing species, in many areas of its range has serotinous cones that are held tight, all the seeds locked up, and when a fire comes, it releases those seeds on the order of hundreds of thousands of seeds per tree when a fire comes. Areas that were mountain pine beetle outbreaks in lodgepole pine forests that then subsequently burned came back thick carpets of lodgepole pine forests, almost as if there was no beetle outbreak there. And that's basically because that species is very well adapted to those dual disturbances, because it can reproduce prolifically following fire. Even in some cases, we saw evidence that cones on dead trees, if they weren't consumed in the fire, could still contribute to that post-fire seed source. But certainly there would still be plenty of live trees, even in a severe beetle outbreak. And all you need is a few live lodgepole pine trees that are just loaded with cones, and you've got a dense stand. On the other end of the spectrum, species like Douglas fir, where there had been Douglas fir beetle outbreak and fire, or Engelmann spruce, where there was spruce beetle outbreak and fire, the answer is pretty different in that those species do not have that seed bank that lodgepole pine has that persists when the tree is dead. Those, Douglas fir, Engelmann spruce, they produce seed annually and shed that seed annually. So as soon as those trees are killed by bark beetles, they're not providing a seed source anymore. And we did see in those forests, when there was a Douglas fir beetle outbreak or spruce beetle outbreak followed by fire, there was a substantial reduction in post-fire establishment of those species because they just didn't have that seed source because it had been taken out by the beetles.
Hey, Brian, I was thinking maybe we could stop the screen share and then we can see you bigger, and maybe that would be like a fun transition into Q&A.
Sure.
There we
No
go.
problem. Can you see? It's almost like I'm still sharing my screen because I have this background going here.
Right.
Yeah, we can see you well. Yeah, thanks.
Yeah.
Brian, we have a great question from Kirsten. I don't know if you can see it there. It's about birds. Birds and specifically about hairy woodpeckers building resilience, potentially building resilience in pine forests. And do you see the question there?
Yeah. Observations, research, finding. Yeah, Diana Six has done some really awesome work at the University of Montana on the beetle outbreaks. And then Vicky Saab, who's also in Missoula, Montana at the Forest Service, she's an ornithologist and has done a ton of work on the effects of bark beetle outbreaks on different guilds of birds. And it's fascinating. I almost feel ashamed to be talking to a group like this because for me, it's so far out of my area of expertise, and I just think it is like really, really awesome and interesting work. But I'm happy to send some links and you all can pass it on. But basically, a lot of the work that Vicky has done and as well as some other folks in the Rockies have shown that, yeah, there are guilds of birds, one of them being, for example, three-toed woodpeckers, that flock to spruce beetle outbreaks and are basically tracking spruce beetle outbreaks around the landscape because as a primary food source for them, one organism's bark beetle outbreak is another organism's feeding buffet. And so there's some really, really important benefits to from bark beetle outbreaks to a lot of the insect gleaning birds that are feeding on those bark beetles. So I would say, in addition to Diana Six's work which is great. Vicky Saab is another person who I'd be happy to send some links or link to her website if folks. You could also just Google Vicky Saab. It's SAAB, U.S. Forest Service. She's done some really cool work.
I think, Brian, I think one of the main questions, I'm seeing a bunch of questions about sort of the different priorities of, say, DNR Forest Service, BLM, land trusts, sort of the push and pull about how to manage forests and sort of, you know, what the effect on that is, what really, you know, different ideas of people have what a healthy forest is. And I'm not sure exactly what the relationship that is of that is to fire, but I see a number of questions around that.
Yeah. I mean, the very big picture answer to that question is, I would say that it is a complex challenge to think about fire, which is a process that knows no borders, occurring on these landscapes that is a very fascinating mosaic of different land ownerships, and within each one of those land ownerships, multiple objectives in terms of how that land is being managed. And so the short answer to that is to say there's definitely not a one-size-fits-all answer to what makes the most sense or how to manage for a healthy forest. I mean, again, in some areas, if you were trying to manage for a healthy forest for three-toed woodpeckers, a bark beetle outbreak is a very healthy forest for that species. If you're trying to manage for species that are late cirral, old growth obligates, you would want to preserve as much of that habitat as possible. If you were trying to manage for species that are early cirral beneficiaries, right? So species that are going to be using as a resource a lot of the high plant diversity that comes up only following a standard placing disturbance like a fire, then you know you'd want to actually protect some of those areas and the diversity within them when they do occur. One way to think about this is that there is a lot that we can do to prepare our forests for fire when it does come, but it's almost impossible to stop fire from coming. It's inevitable. And so another way is, given that fire is going to happen on these landscapes, planning for different management responses in areas where totally different outcomes are going to be appropriate or warranted. I realize that's a little bit of a broad brush non-answer to that very good question, but I think it just depends so much on the particular land manager's objective on any particular chunk of land that answer is going to be as variable as we could probably imagine.
Okay. I'm going to finish up with one final question here. I was looking at the chats, and that is the planting of a single species by, say, you know, a timber company or other agency. Does that affect the severity of the fire on either the east-west side, or is it more what, or potentially the outcome from a fire? What differences are you going to get from the fact that, you know, sometimes they're just planting straight Douglas fir, or, you know, as a merchantable tree?
In terms of what the fire might do, or what might come back after the fire, or just want to make sure?
Well, on the characteristics of a fire potentially, and then also, I think you explained like the lodgepole in the case of lodgepole. If you planted all lodgepole, that's what and you have a severe fire, that's what you're going to get, is all lodgepole back. But is there any example like that on the west side where we've got all this Douglas fir planted? Or what's going to happen?
Yeah, it's a really good question. One way to answer that is we're in the process of finding out, actually. In the North Peak fire, it's been one of the few opportunities that we've seen in this region, at least, right? So not that fires on the west side of the Cascades have been entirely absent. Certainly further south in the Cascades into Oregon, there's been some fire on the west side of the Cascades, but at least in this region, we haven't had a ton of opportunity to empirically answer that question. And so in the North Peak fire, we had fire that burned through 500-year-old old growth, fire that burned through 280-year-old stands, fire that burned through 120-year-old stands, and fire that burned through 40-year-old plantations. And one of the questions we're interested in asking actually is how the post-fire response is going to differ between those categories, or if it's going to differ between those categories. And certainly there are likely hypotheses that, you know, the more large trees you have nearby and therefore seed producing seeds to be able to provide seed input, you may see a stronger post-fire response in those areas, but we really don't know. I mean, that there could be there could have been plenty of seed on some of those younger stands ready to go, and too early to tell, though. I will say I'll be more than happy to come back and share some insights of what we're finding in some of those areas where we do see fire burning through more kind of monotypic stands of a single species in some of our study sites.
Okay, well, Brian, I really want to thank you so much for being with us tonight and presenting. I certainly learned a lot, and I really appreciated all the information you provided. And I think that you certainly had an audience that was very willing to ask you plenty of questions.
Yeah, this has been really great, and I thanks so much for everybody who joined in. The only thing that I'm bummed about is we didn't get a chance to sit around having a snack or something afterwards and chat some more, but more than happy to answer any questions if folks want to follow up via email and continue the chat. I'd be more than happy to.
Right. And thanks to everybody from North Cascade Audubon Society for joining us tonight. And perhaps we'll see you again in another webinar in the future, and hope everybody has some ideas to mull over here and some further research to delve into during their free time.
I'll also just say thanks as well thank you, Stephen, for hosting this, for being flexible with this new platform. Brian, again, thank you for just engaging so much with everybody. The chat, it was so fun to see so many people talking in the chat. And so thanks everybody for tuning in with us. And I put the link to the museum's website in the chat too, and you can check out the new programming that we are bringing to you digitally. So yeah, thanks everybody.
Great, yeah, thanks so much.
Okay, bye-bye. Thanks, everybody.